Looking at our second example, we're going to make a frequency chart and draw the histogram. And in this data set, we have the daily step counts for elderly patients. Now, to make a frequency chart, the first thing you always want to do is find your class width. And the class width is when you find the range of the data set, and the range is the maximum minus the minimum value, and then you divide by the number of classes. In our case, the smallest number is 320. And let's see, our largest number is 1820. So I'm going to take our maximum value, which is 1820. I'm going to subtract 320, and divide by 5. Since we want to make 5 classes here, I have class 1, class 2, class 3, class 4, and class 5. So I'm going to divide by 5. Now, when I take 1820 minus 1320 and I divide by 5, I'm going to get 300. The class width is always going to get rounded up at the end to the next whole number. Even if when you do your arithmetic, that value comes out to a whole number, you still want to round up to the nearest whole number. So that way you have enough room in that last interval or that last class to fit all of the larger numbers in there. We want to make sure that every single one of these values in our data set can fit into one of these classes. So that's why we always want to round up, even if our calculations give us a whole number. So our class width here is 301. All right, now to start finding our limits for each of the intervals, you always want to start at the minimum value for the first class limit, the lower class limit. So we're going to start at 320. That's our smallest value. Then to find our upper limit, we are going to add, put this note in here, to find the upper limit, add the class width minus 1. You don't want to add 301, since that's our class width. You want to add 301 minus 1, which is 300, because we are including that very first value of 320. We are including that in our interval. So 320 is a value, plus I want 300 more to make a total of 301. So I want to add, let me make a note of this. So to find each of my upper limits, I want to add 300, not 301. So when I do that, I get 620 is the upper limit for my first class. Then, when I drop down to the next interval or the next class, I want to go up an integer. So my upper limit of the first class was 620. So in the second class, I want to start at 621. Then to get the upper limit, I'm going to add 300. So that gives me 921. And I'm going to repeat that process. So then on the third class, the lower limit is going to be 922. And I'm going to add 300. So my upper limit is going to be 1,222. And as I repeat that process, I get 1,223 to 1,523. And then the last class, it starts at 1524. Then I add 300 to get 1824. Now, to find the boundaries. The boundaries is what allows us to close the gap, because with a histogram, we do not want any spaces between the bars. And as of right now, if I go from the first class, the end of the first class, which is 620, and then I start the next class at 621, we got a bunch of values in between there. Like we got 620.3 and 620.5 or 0.8. We got those decimal values between 620 and 621. So to close the gap, what we're going to do is we're going to subtract a half from the lower limit and add a half to the upper limit. So we're extending the interval out by a half in each direction, and you'll see how that's going to close the gap. So for my boundaries, I'm going to look at 320, and I want to go backwards and subtract a half. So that's going to give me 319.5. And then for my upper limit, I want to add a half. So that's going to extend it out by a half in either direction. So my upper boundary is going to be 620.5. Now, when I jump down to the next class for the boundaries, we're going to start at 620.5 because that is 621 minus a half. And then I'm going to take 921 and add a half. So my interval for the boundaries for the second class is going to be 620.5 to 921.5. So now we're closing the gap. So if I'm looking at the boundaries, my upper boundary for the first class is 620.5. And then when I jump down to the next class, my lower boundary for the next class is 620.5. So there are no gaps between there. So I'm just going to repeat that process all the way down. Just extend out by half in either direction to close the gap. So that would give me 921.5 to 1,222.5. And then 122.5 to 1,523.5. And then 1,523.5 to 1,824.5. Now, to find the midpoints, you want to take the lower boundary and the upper boundary and add them together and then divide by 2. So we have the upper boundary, I'm going to abbreviate UB, plus the lower boundary, and then divide by 2, and that will give you the midpoint. Now, although we're not going to use the midpoints for the histogram, there are other graphs in another lesson that we're going to use the midpoints for. So we're starting to add it into our chart now so we can start practicing. But just keep in mind, we're going to be using later the midpoints for a frequency polygon. Frequency we're going to use, or relative frequency, we can use for the histogram. And then cumulative frequency we're going to use for a chart later called an ogive. All right, so now taking 319.5 plus 620.5, if I add those together and divide by 2, that gives me 470. So that is the midpoint between 319.5 and 620.5. Now, to find the midpoint for the second class, I'm going to take 620.5 plus 921.5 and divide by 2. That's going to give me 771. And I'm just going to continue that process, and I'll get, for the rest of the midpoints, I'll get 1,072, 1,373, and then 1,674. Now, to find the frequency is the number of times that you see a value in the data that falls between the boundary points. So I'm looking to see for class 1 to find the frequency, how many values in my data set fall between 319.5 and 620.5. If I count all of those values that fall between 319.5 and 620.5, I'm going to have 3 values. For the second class, if I count how many values fall between 620.5 and 921.5, there are 9 values that fall on that interval. And then again, I continue the process. If I look at the third class, there's going to be 7 values that fall between 921.5 and 1222.5. And then I just keep counting. So for the last 2 classes, our frequencies are 9 and 12. Now, there is an easier way that we can use GeoGebra to find all of these frequency values if you don't want to do it by hand by counting the values in the data set, especially if it's a large data set or you have large numbers. Your eyes can play tricks on you and it can mess up all of your counts. So in a bit here, I'm going to show you how you can use GeoGebra to count your frequencies. Now, the relative frequency, that is the percentage of values that lie on each of those classes. Because there are 40 values in this data set, and there's 3 that fall on the first class, that means my relative frequency is going to be 3 out of 40, and then when I round that as a decimal, I'm going to get 0.08. So the relative frequency is the percentage of values that lie on that class, not the count, it's the percentage. So for the second class, I have 9 values that lie on that interval. So to find the percentage, I'm going to take 9 out of 40, and that's going to give me 0.23. Whoops. Okay, now for the third class, I'm going to take 7 out of 40 to find my percentage, and that's going to give me 0.18. For the fourth class, it's 9 again, and we already found that value, so I'm just going to take 9 out of 40, and that's 0.23. And then the last class, we have a frequency of 12, so I'm going to take 12 out of 40, and that's going to give me 0.3. Now, because these are the percentages for each interval, if I added all of my frequencies correct and I did my relative frequencies correctly, 0.08 plus 0.23 plus 0.18 plus 0.23 plus 0.3, all of those relative frequencies should add up to 1, which is the decimal format for 100%. So that's a nice way you can check to make sure you got the right answer. Now, if you're rounding your relative frequencies, that might be slightly off from 1. You might get like 0.998 or something that's really close to 1, but it may be a little bit off from rounding, but it should be close enough that when you check it, you can see that you've done it correctly. Now, for the cumulative frequency, we're just going to add up the frequencies for each of those levels. So for the first level, we have a frequency of 3. So I'm getting it from my frequency column. Up to the second level, I have a frequency of 3 plus 9. So I want to add those together. So everything up to the second level or the second class, I have 3 plus 9. That's going to give me 12. For the third cumulative frequency, I'm going to add the first, second, and third class frequencies together. So this is going to be 3 plus 9 plus 7. That's going to give me 19. For the fourth class, I'm going to add all of those 4 classes, the first 4, I should say, the frequencies together. So that's going to be 3 plus 9 plus 7 plus 9. And when I do that, I'm going to get 28. The last class, I'm going to add up all of the frequencies, and because I'm adding all of the frequencies, it should total to the number of data values that we have. So I'm going to take 3 plus 9 plus 7 plus 9 plus 12. I'm going to add them all up, and then I get 40. If this number does not come out to the number of values you have in your data set, you made a mistake somewhere and you got to go back and double check your work. All right, let's draw the histogram by hand. The vertical axis always is going to be our frequency. Now, the highest value I have for our frequency, the largest frequency is 12. So when I scale that, I want to make sure that we scale it appropriately and I don't go too far out past 12. I'm going to scale it by 2s, 2, 4, 6, 8, 10, 12, 14, 16. All right, now on the x-axis, we're going to label what the data represents, which is step counts. It's daily step counts. And we always want to use, for this class, I know some people do it differently, but for my class, when we draw these by hand, we're going to use the boundaries. So I'm going to start at 319.5. Then we have 620.5. Then we have 921.5. Then we have 1,222, 0.5. And then we have 1,523.5. And then the last value for the boundary is going to be 1,824.5. All right, so let's graph these. For the first class, I have 3. So when I draw my bar, I only want it to go up to 3, and I'm going to put a little 3 above it. For the second class, we go out to 9. For the third class, we go to 7. So that would be about right here. Then we go back to 9. And then to 12 for the last class. The last thing that we need to do, it looks like it's done, but we're not quite done. Remember, we didn't start at 0. We started at 319.5. So I'm putting that compression symbol in there. So we are compressing the x-axis between 0 and 319.5. So let's switch over to GeoGebra and check our work. So from the homework, we can access GeoGebra. If you don't already have your window open, I'm going to go to spreadsheet view. If that doesn't open for you automatically, you can find it by going to the 3 lines here and go to view. And then you want to click on where's spreadsheet. Here it is, spreadsheet view. If you don't want the graph there, you can just uncheck that, give yourself a little bit more room. Now, take a minute and pause the video and enter in your 40 values here. If you don't want to delete what you already have in row A, you can just start a new row and put it in row B. If you want to sort them, you would just click SORT. You would choose list. And then because I'm putting mine in the B column, I would do capital B1 because that's where my data starts. Then I would use the colon. And then I would put in B40 because that's where my last data value is at. And then I hit enter. And then it stores my data for me. Now, if I want to make a histogram and a frequency chart in GeoGebra, I want to highlight my data values and those data values only. Don't highlight anything extra by mistake or miss something because then that will throw your answer off. Once you have all that data highlighted and you choose, go to the bar graph icon here and click one variable analysis, and a bar graph will come up, but you want to make sure it's set up with your boundaries and everything. GeoGebra automatically sets up a bar graph for you, but we need to make sure that it has the right number of categories and everything. So we want to click the little gear. We want to choose set classes manually because we want to set our boundaries the way that we have it on our paper. Now we're going to start at our lower boundary for the first class. Our lower boundary for the first class is 319.5, and then my class width is 301. So you can check this against what you drew to make sure that you drew it correctly. And then if you want to see your frequency table, you can click this box right here, and below it will show you your boundaries. And it will show you the frequency so you can check. Now, those are your counts. That's your frequency. If you want to check your relative frequency, your percentages, you can click this button here, and that will change your relative frequency. If you want to see your cumulative frequency, you want to click count and then make sure you're checked on cumulative, and you can make sure that you have those values correct. Then your graph is going to go consistently up from the left to the right because you're adding them as you go. So for the first class, you have a count of 3. The cumulative frequency for the second class is the first and the second class added together to give you a 12. So that now changes the graph. Instead of having your counts, you're having your cumulative frequency. So it's going to graph these values instead. So be aware of that. If you're checking your graph, make sure you have the correct options highlighted here or checked. All right, so the final thoughts for this lesson. Today we use descriptive statistics to summarize raw data using intervals and categories and then graphing them in a histogram. Remember, in order to find the width of the bars of the histogram, that's your class width, and you want to make sure, even if you come out to a whole number when you do your calculation, you always want to round up, not down, round up every time to the next whole number. We build frequency charts to show those patterns and to show the intervals, and not all of those columns in the frequency chart have we used yet for graphing, but we will. And the histograms are for visualizing frequency, which is a fancy way of saying the counts in that category. We learned how to calculate midpoints and boundaries, and very important in this class, I know some people do it differently, but in this class, I'm very strict about making sure that we're using the class boundaries, not the limits, to graph our histograms. You may see other questions or in other books that some people like to use the class limits, but I like personally to use the class boundaries. And then one last thing to bring up is that for a histogram, we're specifically using quantitative data. And GeoGebra, you can use it as a tool to check your work, but it's not going to truly help you unless you understand what you're looking at. So make sure you understand it and don't just plug in the values. So if you have any questions on how to use GeoGebra or any questions about frequency charts and histograms, please ask me in class or through email.